Hello and welcome to New York Times Hard Sudoku. Today is the 30th of January 2023. I was kind of prevented from doing the hard puzzle yesterday. I had a video call and a language exchange, Spanish and German, with a woman in Mexico. And in the afternoon, I was invited for lunch. And full disclaimer, after that lunch, I wasn't in the mood for solving Sudokus. So we will catch up today and look at this puzzle here. 161616. If we didn't have this pattern, it wouldn't be a New York Times hard puzzle, would it? So these are ones and sixes. And that means that this 3 blocking up here and the 3 blocking over here makes this a 3. So we got a 3 here, 1 6 here, 7 up here, 7. So 7 7 7. A 4 blocking over here, so one of these is a 4. And we have a 4 coming over here, and we have got this 4 coming down here, making this a 4. And speaking of 4s, we have a couple here making one of these a 4. We got a 5 and a 5 blocking over here. The 5 coming down here, this is a 5. So 1 5 here, 1 5 here, making one of these a 5. This 8 and this 8 puts an 8 up here, doesn't it? And this 9 puts a 9 here, here, or here. And by the way, speaking of 9s, this 9 is blocking here, this 9 is, so one of these is a 9, making one of these 3 guys a 9 as well. What else can we see? What's going on with the 3s? 3 coming down and up and over, one of these is a 3. And one of these is a 3, 3 here, 3 here. But we got a 3 bearing down on this square, so it can't be a 3. This must therefore be a 3. We got a couple of 6s going across, so this is a 6. And we also have these 2 6s. So one of these 3 must be a 6 now. What else is going on here? A 3 coming up, a 3 coming over, and a 3 coming over, making this a 3. And now one of these must be a 3, along with one of these. Can't be resolved just yet. There's a 2 going over here and a 2 coming down here. So one of these must be a 2, and therefore one of these must be a 2. A 1 bearing over here, and therefore one of these is a 1, and therefore one of these is a 1. We still need a 1 for the center column. And it can't go here because of this 1. Therefore, one of these must be a 1. Can we get any closer? No, I don't think we can. Can we say something about the 6s? Well, yes, I think we can, because neither of these can be a 6, and this can also not be a 6 because of the 6 here, here, and here. Therefore, this is a 6. And now we need 1, 2, 4, and 7. No, can't resolve that yet. One of these now is a 6 along with one of these, which is also a 1. One of these is a 4. I was seeing if I could find a 4 for this row, but a 4 could also go here conceivably. So that is not going to fly. What about across here? 2, 7, 8, 9. We have a 7, 8 here, so this is a 2, 9. We have an 8, 9 here, so this is a 2, 7. And we know that an 8 must go here, yes, because of the 8 here and here. But the 9 The 9 is elusive. But a 6 needs to go here because there is no other free cell in this row. So this is a 6. That doesn't do much though, does it? But we still need to find place for a 7 and a 3 here, 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 here. So one of these must be a 7, right? Therefore, one of these must be a 7. What about the 3? Well, the 3 could go here or here. Not much help. I am seeing the 4-7 blocking here, and I'm seeing the 4-7 blocking here. Unfortunately, that still leads 3 squares for a 4 and a 7. Except, of course, this square can't be a 4 due to the 4 up here. Oh, hang on. I have no idea why I overlooked this. This must be a 4 because we got 2 4s here already, don't we? So 1 6 7 8 9, and these must be 8s. So this is a 7 9. Seems to me that the 9s are very restricted. This could be a 9 and this could be a 9. And if I look down here and I just start counting, I know this is caveman style, but let's just do it. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is an 8, 9. And that is kind of a restrictive, isn't it? And this cannot be an 8, 9. This cannot be an 8, 9. So this, what can this be? It could be a 1, yes, 2, 3, 4, 5, 6, 7, 8, and 9. It could be a 1, 8, 9, except it can't be a 1 because the 1 goes over here and comes down here. So one of these here is a 1. So this is an 8, 9, and this is an 8, 9. That leaves a 4, 1, and a 7. And we know that the 1 must go over here somewhere. So this is a 4 or 7. And that is, I think, as far as that takes me, except, yes, except that one of these now must be an 8. If one of these is an 8, 9, this cannot be an 8, and this cannot be an 8 because of this 8. So this is an 8. Yeah, and that makes this an 8. Now we're getting somewhere. Now 1, 4, 7 for these guys here. This is a 4, must go here or here. 1 must go here, and 7 can go, sadly, anywhere. But now we found this 8, and we have this square blocked by the 7 here, and this square blocked by this 7. This must be a 7 that goes here. Now this is a 9 and a 5 to go here. And we've got, and yes, one of these must be a 9. 9 goes, not one of these must be a 9. Fine. Yes, I got it. Now we have a lot of restrictions here. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a 2. Now one of these must be a 2. And I remember that one of them had to be a 6 as well, but that was one of those. So 2 and 6 must share 2 of these 3 empty squares. What else is coming down here? 7, 9, and a 1. Well, that is not clear yet. Wait a moment. What can go in here? 1, 2, 3, 4, 5, 6, a 7, 9. And we also had a 7, 9 over here, remember, because one of these is an 8. So this is a 7, 9, and this is a 7, 9. So now we only need to fill 4 squares. And we know that these are 1, 6. So it's 2 and a 5 we are still missing. And that doesn't do anything for me, does it? Well, maybe this knowledge will come in handy a little later. Yes, but the 7, 9 and the 7, 9, they have one advantage. They rule out a 9 from this square, and these three can't be 9s because of this 9, and this can't be 9 because of this 9, so this is a 9, and that makes this a 9. And now, what can we do up here? This was a 7, 8, 9, right? One of these must be an 8, and so one of these is a 9 now, making this a 9. And surely that means something over here. Yes, one of these is a 9, but we knew that because the other one is a 5. But what did it do here? One of these is a 2. We know that. One of these is a 4. What's the last digit? It's a 7. No. But 1, 6 here, and this can't be a 2. So this is a 2, and this must be an 8. And that makes one of these 2 and 8, doesn't it? And one of these two must be a 4 and the other must be a 7. We have a 4 in the column, making this a 7 and this a 4. Now 7 coming over here and down here, we still have 3 empties. Oh, but this can't be a 7 now, so this is a 7 and this is an 8, 9, making this an 8 and this a 9. And now we got the 9 coming up and the 9 coming over, so this is a 9, making this a 9, and this must therefore be a 2. 5, 6, 7 here. There's a 7 here, so one of these is a 7, and one of these is a 5, and one of these is a 6. So the 7 goes here, and here, along with the 5, with the 4. We had a 4 here as well, right? So that makes this a 1, and this must now be a 1. The last digit here has got to be a 9. Now, this must be the 5 that we missed before, and this, of course, now has got to be a 3, making this a 3 if memory serves. One of these must be a 5, I remember that, and the other must be a 2. We have a 2 in the row, so 5 here, 2 here. 5 here or here, but it can't go here because of this 5, so this is a 5, making this a 5, and this a 5, and this a 6. And this a 6, and this a 1. 1 goes here, and this is a 2. 2 going down, 2 going over, 2 going over. This is a 2, therefore this is also a 2. This must be an 8, making this an 8 and this. This is all from memory. We've been over this a few times already, so there is nothing magical about this, or magic. This has got to be a 1, making this a 1. And this, therefore, a 4. I believe, yes, and a 4 here and a 4 here, and therefore this is 7, and this must be a 7. And this. That wasn't too bad a puzzle, I think. I would say it was rather easy. But you can't win them all. I hope that you enjoyed it, and I thank you for going through it with me, and I welcome you back here again soon. Goodbye for now.